Again, drawing a picture might be helpful, but I realize it might get a little bit difficult. So the assumption is that there's going to be some length on the interval between 0 and pi over 48. And kind of looking at it, the cosine of 0 is 1. I can take the natural log of 1, certainly. And pi over 48, that'd be pi over 3. So I realize I can certainly do that. I get the natural log of that. And what I want to do is just, write down I'm hoping this works out really nicely for you. I'm going to be putting out dy dx. And let's be careful with that. There's a constant there, which is 1/16. And now I'm going to take the derivative of natural log, which is 1 over its argument. So that's 1 over the cosine of 16x. And let's take a look next. I have the derivative of cosine, which is minus sine 16x. And then the derivative of the inside of that, which would be 16. I'll put it over here. So we get something pretty nice. I get dy dx equals minus, well, sine over cosine's tangent. And that's of 16x. That worked out pretty nice. Now I'm going to set my integral up. And it's going to be the arc length now. It's going to start at 0. And it's going to go to pi over 48. And what do I get over here? I get 1 plus. And let's be careful about this. We have to square that. So you get tangent squared of 16x dx. Well, that's recognizable. Now let's keep moving. So you get 0, pi over 48. 1 plus the tangent squared is secant squared. 16x. That's the root of that, dx. And I do want to point out that, the square roots can be difficult because you have to do the absolute value, but what do I notice about this? Between 0 and pi over 48, the secant is definitely a positive number. So I can just simply do this now, secant of 16x dx. I realize what happens to a lot of students they're wondering what to do now, and sometimes I would wonder too, do I know that guy's antiderivative? Well, I'm not saying it's fresh in your memory, but certainly I think you've remembered that we've done something like this. You may have to look back over your notes, but this is not a bad antiderivative. I'm not asking you to memorize things though, but what do I get over here? I kind of remember. If you want to do maybe I'll do a u substitution first. What's the u going to be? 16x, and du would be 16 dx. So what do we get over here? Let's put this 0 down. Going to land of u's. So if I put 16 over there, well, 16 times pi over 48, pi over 3. And then you're going to get, secant of u. What's du going to be? It's 1/16th, right? It's 1/16th of a du is dx. Put this over here. And I think I'm ready to do it. Again, if you can't remember the antiderivative of secant u, I understand that. Just ask or look it up. It's going to be natural log, absolute value, secant of u plus the tangent of u, and that goes from 0 to pi over 3. All right, I want to do the arithmetic now. And what do you get? 1/16 and natural log. Whoops, that's an ln, by the way. And let's take a look. It's pi over 3, right? Pi over 3 is 60 degrees. So I get a 60-degree triangle. Let's select this over here. Root 3. This would be 1 and 2. So the secant of that would be 2. Plus the tan of that would be root 3. That's not so bad. And now it's minus the natural log. I'm sorry, 1/6. Natural log, absolute value. Well, the secant of 0 is 1, and the tan of 0 is 0. What's nice about that, it evaluates to 0. The natural log of 1 is 0. And I'm going to simplify this now. What are you going to get? 6 on the bottom, and this is natural log. You can actually remove the absolute value symbol because 2 plus root 3 is a positive number. And then I'd get my red pen out and see if you got that answer. Yeah, sometimes I make mistakes, and you want to go back over your work if you are making mistakes. You just redo the problem, and I am seeing that right over there. And we're done. Thank you.